You are welcome to today's class. In our video today, we'll be looking at frictional force and coefficient of static friction. We want to look at the relationship between the two, the equation that connects frictional force and coefficient of static friction together. Now, from the properties of frictional force, one of its properties states that frictional force is directly proportional to normal reaction. Frictional force is directly proportional to normal reaction. This is variation. If you change it to equality sign, it's going to attract a constant. The constant that it attracts is what we call the coefficient of static friction, where this is the frictional force. This is the coefficient of static friction. Then this is normal reaction. So the relationship between frictional force and coefficient of static friction is given as this. Let's make coefficient of static friction subject of the formula. It's going to give us frictional force divided by normal reaction. Here, normal reaction is measured in newtons. Frictional force in newtons, normal reaction also in newtons. Therefore, coefficient of static friction has no unit. What we want to look at now is to see how we can determine the coefficient of static friction. Determination of the coefficient of static friction. In order to determine the coefficient of static friction, an inclined plane is what we need. An inclined plane is a plane that makes angle theta with the horizontal. Before I proceed, let's look at inclined plane. This is an inclined plane. An inclined plane is just a slopy plane that can be used to lift up an heavy load up a platform. Now I want to look at it. A body can be here. Let's call their body A. We want to determine the coefficient of static friction. Look at this body now on this inclined plane. Without anybody touching this body, it's going to slide down. Let's now assume that this body is constant there, is not sliding, which is not possible. Let's assume that it's possible. It shows that something is holding it. Now, if this body wants to slide down, the direction of its acceleration is going to be downward, which means that frictional force will be opposing the direction. Now, something is happening here. When a body, it's just like when a body is standing on the floor, there are two forces acting. We have the normal reaction from this plane. This is the normal reaction. Then the weight of the body goes this way. This is the weight of the body. Weight of a body is always, the weight of a body, according to gravity, is always normal to the ground, perpendicular. This is the weight, mg. Then let's get the sense of the normal reaction, which will go this way. Now what we want to do now, we want to resolve along the plane and vertically with the plane. But if you look at this, you can see this is along the plane. Assuming that this force is not there, this one will slide down. It shows that there is a force that is causing this body to slide down. You will see that the body will just be sliding down without anybody touching it. The force that is here is the one causing it. How can we derive this force? That is, the force is what is, you can see that it's along the plane. So we need to resolve along the plane, and we also resolve perpendicular to the plane. Now let's call this place, let's call it S, and let's call this place, let's call it Y. Now if you now look at this angle is now here. We can join these edges together, trace it here, in order to form a right angle triangle. Then you trace this to this, so that this and this can be parallel. Then you can now see that the plane and this one also, they are also parallel to each other. So now this angle is 90. Now let's bring out this small triangle that we are seeing here. Let's bring it out. We can now see that we have something like this. This is the triangle. This is the triangle. This is 90. This is where we have S. Then this is where we have theta. Then here, since it is parallel to the plane, this is Y. Now we can see, according to the diagram, we can see it. This can also be called Y. Then if you look at this, this is the weight of the body. That is the hypotenuse of the triangle. So the weight of the body can be found here. So what we are going to do now is for us to solve for X and Y. Let's look at it. Sine theta. Sine theta is equal to opposite over hypotenuse. Therefore, that is resolving along the plane. Resolving along the plane. Resolving along the plane. Resolving along the plane. If you make Y subject of the formula, we are going to have mg sine theta. You can see, which means that the force that is causing the body to slide down is mg sine theta. So this place is mg sine theta. Now let's look at the force that is what? That is perpendicular with the plane. Is by resolving perpendicularly. Resolving perpendicular with the plane. With the plane. Resolving perpendicular with the plane. That means we are going to solve for X. In this case, we use cosine cos theta equals to adjacent over hypotenuse. Adjacent over hypotenuse. So our S is going to be S equals mg cos theta, which means that this is mg cos theta. So this is how we get the forces, all the forces that are acting on the body A. How can we now determine the coefficient of this friction? Now we can see now from here at equilibrium, that is when the body is not sliding down. You see that the frictional force is going to be mg sine theta. When the body is not moving, when it is not sliding, the frictional force, the force that we have here, which is going up, is going to equal to the one that is coming down. Likewise, normal reaction is equal to mg cos theta. Mg cos theta. That is, on the plane, the normal reaction is equal to the downward, that is, the upward force is equal to downward force. The downward force is mg cos theta, while the upper force is what? Normal reaction. In this case, the weight of the body is not the downward force, because to the plane it's not perpendicular. So you look at the one that is perpendicular to each other. You can see normal reaction is perpendicular with the plane. Then mg cos theta is also perpendicular with plane. So this is the upward force, this is the downward force at equilibrium. They are the same. So from the property of frictional force that says that frictional force is equal to coefficient of static friction multiplied by normal reaction. If you now make normal reaction subject to the formula, we say that coefficient of static friction subject to the formula, we are going to have frictional force divided by normal reaction. Now let's substitute. Don't forget that frictional force is equal to mg sine theta. That will be mg sine theta divided by the normal reaction. Don't forget that the normal reaction is mg cos theta, which is mg cos theta. Now you can see that mg will cancel mg, which will be coefficient of static friction will now equals to sine theta divided by cos theta. In trigonometry, one of its identities is sine theta divided by cosine theta is going to give us tangent. So this is the coefficient of static friction. This is how to determine the coefficient of static friction. If you have any question that has to do with this, don't forget at the comment section, make sure you drop your question so that we can attend to it in our next video. This is how we can determine the coefficient of static friction. It is very important in solving any question that has to do with friction. Take it very, very important and take it seriously. Thanks for watching.